Welcome back to Outward Home Learning. The subject is computer science, and today we're looking at reading algorithms. So for this, we're going to go over to Mr. Holton, who's going to tell us how we can successfully read algorithms, and then you've got a couple of tasks followed by exam questions. Over to Mr. Holton.
A key skill that you'll need when you're programming is to be able to have a look at a section of code and sort of figure out what it does. And we can describe that as reading an algorithm. And there's different kinds of algorithm we can read. We can read pseudocode and we can read flowcharts. This video is going to focus on pseudocode, how to read it, and how to figure out a result from a set of instructions. So let's have a look at this particular algorithm here. We've got the idea here. I've got number equals input, enter a number, smaller equals number minus 2, and then I'm printing out smaller times by 4. So let's follow along and see what happens. So if you see, I've got this variable here, number, and that matches the variable I have over here called number. And here's where I'm inputting data, so input, enter number. So what I can assume is that the first time round this algorithm, the number 3 is going to be used. So I need to figure out what the output is from that. And then the second time round, I'm going to do the number 7. So let's figure out number 3 first. Number is a variable, so look at the variables video if you're not sure about what a variable is, but basically it's sort of like a box that contains a value or a bit of text. In this case it's a number, and it's called number, which is nice and convenient. Okay, next slide. So I've just set the number 3 there because the number 3 is there. Okay, so that's our first input. Smaller equals number minus 2. Well, that creates a new variable called smaller. So I've got another box called smaller, and then I'm going number minus 2. So what's number 3? What's a number? The number 3, and then I subtract 2 from that. So that means in smaller I've got 1. And then I'm doing this print, which is my form of output. Anytime I've seen print, I'm outputting smaller times by 4. What's it smaller? Number 1. So 1 times by 4 is 4. So there's a few numbers there, but hopefully that sort of makes sense. Let's see if you can follow along with 7 and see if you can figure out ahead of me. Okay, we've got the same sort of variables here. So we've got number equals 7. Smaller therefore is going to be 7 minus 2, which is 5, which means we're going to print out the number 20. So far so good. I mean, that is a fairly straightforward algorithm which only features sequencing. So the idea that we do this line first, then this line second, and we work our way down, this line third. Now we're going to move on to a problem which has got a little bit of selection in. So for you to be able to do this one, you're going to need to understand how selection works. So have a look at the video about that if you need to. But it's just this idea that our program can follow one of 2 different paths depending on a condition. Let's sort of follow along. Okay, value equals input, enter a value. So let's have here a box. Imagine I've got a variable here called value. And then it's input a value. So our first one here, I'm going to choose a different color. Our first one here is 300. So value is going to equal 300. Value equals value minus 100. Okay, what's happening here? Because this is the same name, value here and value there. You might see this in an algorithm. Well, what actually happens is this bit is worked out by a computer first, and then the result is stored into the variable. And if it's the same variable name, it just means that we're basically replacing what is in this box with a new value. So value minus 100, at the moment it's 300. So if we subtract 100 from that, then we're going to end up with 200, aren't we? Okay, so value is going to have 200 in it at this point. It's really important as you're doing and follow along these algorithms, you keep track of what are in variables as you are going along. If you don't do that, you won't be able to figure out exactly what the algorithm is doing. Next bit here, here's our bit of selection. If value greater than 500, and what I'm going to do now, I'm going to underline the condition in orange. So value greater than 500. So what this means is if the value is greater than 500, I'm going to do this. If it's not, I'm going to do this. Let's have a look. What is in value? It is 200. Is 200 greater than 500? No, it's less than, which means I'm going to do this here, print the value. So I end up with 200 here because that's what's in my box. Okay, let's do the next one then. So 700 now. If value is 700, what happens? Well, I just need to follow along from the top again. So let's do this line of code at the top first. So that is where I'm going to put, so this line here, that is where I'm going to put whatever value is here into my box. So 700 is now in value. Then this line of code next, value equals value minus 100. Well, we know that just basically means we're subtracting 100 from value now. So that is going to make that 600. Okay, next line. If value is greater than 500, then print too big. Is value greater than 500? We're looking at this condition, value greater than 500. Yes, because value is 600, isn't it? So if value is 600, then I'm doing this bit, print too big. So actually in this case, I'm not outputting a number, I'm outputting the words too big. Okay, our last one. What happens when the value is 600? Let's see if we can figure this out. So set up as we did before, value equals 600. So I'm doing this line to begin with. So value equals 600. Value equals value minus 100. So I'm going to subtract 100 from that. Like I said, what happens, this part, number one here, gets worked out first, and the result gets stored back into there. Just a little trick that you need to pick up if we have a variable of the same name. So 500, right. If value is greater than 500, right. Is value greater than 500? It is 500. So is it greater than 500? No, it's equal to 500. That's really important to pick up. That's a common problem that might be thrown at you, trying to figure out greater than or greater than equal to. In this case, 500 is equal to 500, not greater than 500, which means we're not going to do the top half of this. We are going to go down to here where it says print value. So what value we're going to get? Well, yeah, it's going to be 500. That's what's going to be output. All right, so that's how you can follow along with sequence and selection sort of algorithms. When we start to get onto algorithms which got iteration in them, it's usually far better to use trace tables. So we'll have a look at the video for that to see if we can follow along for those kinds of algorithms.
Okay, so it's now time for you to complete the reading algorithms task. For this, you'll be given a number of scenarios and you need to be able to identify the outputs from the given algorithms. So for this, you've got 10 minutes to complete the task and then we'll review your answers. And that is time up, so it's now time to review your answers. We'll go to Mr. Barnes to do just that.
Okay, let's have a look at this activity about reading algorithms. So you've got a number of different algorithms, and the idea is what you need to do is you need to work out the follow the algorithm through and complete the tables. So start with algorithm 1. The diameter is our input. We've been given 3 examples here, and we need to work out what the output is. Okay, so we've got 3.4, so we need to divide our diameter by 2 first of all, because brackets first, which is 1.7, and then this is the exponentiation sign, and we need to, that means to the power of, so we need to times it by itself. So 1.7 times 1.7, which is 2.89. Then we need to times it by pi, times by 3.142, which gives us the answer 9.08038. So let's do the next one. So the diameter is times 6. 6 divided by 2 is 3. 3 squared is 9. So 9 times 3.142 is 28.278. And then finally, we've got the diameter of 2.8. So 2.8 divided by 2 is 1.4. 1.4 squared is 1.96. Timesing that by 3.142 gives us 6.15832. Okay, so there's your answers for the first algorithm. Second algorithm, then we've got something to do with a bill and a restaurant. So we've got our 2 inputs here, the values. So our tip is the bill times 0.1, so 10% of the bill. So the tip, if it's £57.60 for the bill, is going to be £5.76. The total is the 2 added together, so those 2 added together is 63.36. And then the cost each is the total divided by the number of people. So 63.36 divided by 4 is £15.84. And obviously I've used a calculator for that. Next one then is £121.80. So the tip this time is £12.18 because that's 10%. The total, which is the bill plus the tip, is £133.98. And then the cost each is that total divided by 6, which equates to £22.33 each. Last but not least then, we've got the bill. We need to work out 10%. So 10% of £33.20 is £3.32. We add it to the total to give us £36.52. And then divide it by the number of people. So 36.52 divided by 2 is £18.26. And there are your answers for the first 2 algorithms, and these make use of just sequencing. We're now going to have a look at an algorithm that makes use of selection. Okay, so we've got quite a big algorithm here. Let's work through it. So we've got something to do with price, stock level and customer. We've been given that information. So starting at line 4 then, if customer equals Y, well, customer does equal Y. So then we do if price is greater than 50. Well, the price isn't greater than 50, so we do the else part, total equals price. Okay, so whatever my price is, total is now the same. And if we skip the else part because that's if the customer is not Y, and print total. So the total is going to be 35.20. Let's do the next one then. We've got customers Y again, great, so let's go into that. So is price greater than 50? Well, it is this time. So the total is the price take away 5. So £145.60 take away 5 is £140.60. We miss the else part and then print out the total. So £140.60. Okay. Next up then. So this time, is the customer Y? Well, no. So we jump straight to the else part. If the stock level is greater than 100. Well, the stock level is 15, so we ignore that. Else if, is the stock level greater than or equal to 10? Well, it is because it's 15. So the total is our price take away price times 0.1. So if our price was £75.80 and we times that by 0.1, that gives us £7.58, and then we take that away from the price, that gives our total as £68.22. Okay, and then last but not least then, is customer Y? No. So we go to our else part. Is the stock level greater than 100? Yes. So we do the price times 0.2, so £56.70 times 0.2, which is £11.34, and then take that away from the £56.70. So that gives us 45.36. And as you see, this algorithm makes use of selection. Okay, moving on. Now we're going to get interesting. So we're now on to some algorithms that we need to read that have loops in them. Okay, so there may be more than one output here. So we've got our input, so number is 4. So for x equals 1 to number, well, number's 4. So that's like saying for x equals 1 to 4. Square equals x times x. Well, x starts at 1. So 1 times 1 is 1, and then it prints square. So I'm going to print number 1. Next x. So x, what that means is it increases by 1. So x goes from 1 to 2. Is that within 1 to 4? Yes. So we do square equals x times x. So 2 times 2 is 4. And we print it. Next x, so x becomes 3. It's still between 1 and 4, so we go again. 3 times 3 is 9. Next x becomes 4. Is it between 1 and 4 inclusive? Yes. So 4 times 4, 16. Next x becomes 5. It's not within those boundaries, so we stop. Okay. So hopefully you've worked out what happens now. So the next one, number 6. So that's like saying for x equals 1 to 6. So it's going to go in. 1 times 1 is 1, 4, 9, 16. So that's when x is 4. X is 5. So 5 times 5 is 25. X is 6. 6 times 6 is 36. X is 7. It stops. Next one, number is 3. So we go in. 1 times 1, 1, 4, 9. And then x will have gone above 3, so it stops. And then finally, x is 7. So that's the same as 6, but it just goes one more. So we've got 1, 4, 9, 16, 25, 36. 7 times 7 is 49, and then it stops. Okay, so that x is that counter variable. Right, algorithm number 5 then. So very similar in a lot of ways. The loop works in exactly the same way. The difference here is we've got an if statement as well. So we've got if x mod 2. So what mod does is it divides the first value by the second value and gives a remainder. Okay, so if the number was 4, so for x equals 1 to 4, so x starts as 1, sorry. So if 1 mod 2, so 1 divided by 2 would give the answer 0, remainder 1. So it gives the remainder, only the remainder. So it gives the answer 1. So if 1 equals 1, well it is. Sum equals sum plus x. Well, sum is obviously at 0. X is 1. So sum at this stage, if I have x here, so sum is just 1. So we go next x, so x becomes 2. Okay. This time, if 2 mod 2 equals 1, well 2 divided by 2 doesn't give a remainder, so it will jump past that and not do anything, so sum stays as 1. X now becomes 3. Well, 3 mod 2 does give the remainder 1, so sum equals what it was, which was 1, plus x, which is 3, which gives the answer 4. X is now 4. 4 mod 2 doesn't give a remainder, so it's 0, so if 0 equals 1, no. And then so that stays as 4, and then it becomes 5. Okay, and then it would stop and print sum. So the output for the first one is 4. Now instead of doing all of this over and over again, I'm then just going to keep picking up where we left off, because where the numbers change is pretty much the same. So x was 5, it doesn't do it. So now the number is 6. So x is going to go all the way up to 6. So x is 6. 6 mod 2. Oh, I do apologise. Sorry. Let's skip back. So we went up to x is 4. Now we can go as far as 5. So 5 mod 2 does give a remainder. So that gives the sum plus x. Well, sum was 4. X is now 5. So that means sum becomes 9. X now increases to 6. If x 6 mod 2 equals 1, which it doesn't because it doesn't give a remainder, therefore sum stays the same. Okay. X goes to 7, it stops the loop because we were stopping at 6. So when when the number is 6, sum is 9. Okay. Instead of doing it again, number's now 3 this time, so let's just look at the list we've got. So x is 3, sum is 4. And then finally, when the number is 7, so 7 mod 2 does give a remainder, so sum equals sum, which was 9, plus x, which is 7, gives the answer 16. X would then increase to 8 and the loop would stop. So there are your answers for algorithm number 5.
The final part of this lesson is for you to complete some exam style questions. There's about 3 questions there for you to complete and you've got 10 minutes to do that. It's very similar to the skills that you've been practicing already. 10 minutes starting now. Finally, we're going to go across to Mr. Barnes to review those answers. Please make sure you amend them if you need to.
Right then, let's have a look at these questions, a part of our deliberate practice. These ones are all about reading algorithms. So we've got here a mail order company buys dresses from America and France to sell in the UK. The company uses the following algorithm to convert sizes before printing them in its catalogue. Half sizes are not possible, e.g. size 12.5. So we've got some code here. If I just move that up a little bit, it says the company sells the following dresses, and then it gives 3 different types of dresses. State the size which will be printed using the algorithm. So let's start with dress A. Origins France. So we get our inputs. If origin equals America, well, no. So we go to the else. If origin equals France, well, it is. So then it says size equals size minus 26. So the size was 40. It says take away 26, which would be 14. And then end if print size. So dress A will be 14. Dress B then. So origin's America. So if origin equals America, well, it is. Size equals size plus 2. So the size is 8. We add 2 to it, we get 10. Because this first condition's met, we go to the end if and print size. So the answer is 10. And then finally, we've got UK size 12. So if origin equals America, well, it's not. So we go to the else part. Is the origin equal France? Well, no, it's the UK. So we go to that end if, and print size. So nothing is changed. Therefore, we have 12 as the answer, sorry. So let's have a look at the mark scheme. For the reasons I've just specified, we've got dress A is 14, dress B is 10, and dress C is 12 for 3 marks. Okay. So moving on to the final question as part of our deliberate practice. So we've got here, Santos is writing a program that guesses the number of goals a team will score in a football match. The algorithm for his program is shown below. I'm just going to move this up a bit. So we've got an algorithm here, 10 lines. State the number of goals that will be output by this algorithm for the following inputs. Explain how you obtained your answer in each case. Okay, so wins is 30, losses is 25. The first one is 2 marks. So let's go. Input is wins. So we input here 30. We input losses 25. Goals is 0. Net equals wins take away losses. So 30 take away 25 is 5. While net is greater than noise. Well, first of all, let's explain what we've done here. So net equals 5 as wins, which is 30, take away losses, which is 25, equals 5. Okay. So while net is greater than noise, well, net is 5, noise is 10. Is net greater than noise? So net is not greater than noise, and this is a while loop. So while loop not entered, therefore it prints goals. Well, goals was 0, goals hasn't changed. Okay, right, now we need to do the same thing again, but this time wins 20, losses 5, and this is worth 3 marks. So let's do the same thing. Let's put a line through these. So wins is 20, losses is 5, so net becomes 15. So I'm going to write in my answer at the bottom, net equals 15 as wins 20 minus losses 5 equals 15. Net, which is 15, is greater than noise, which is 10. Okay, if we go back up, noise is 10. So while net's greater than noise, so goals equals goals plus 1. Okay, net equals net take away noise. Okay, so goals equals 0 plus 1, so goals becomes 1. Net minus net equals net minus noise, so net, which was 15, equals net So I should move this up so you can actually see what I'm writing. 15 take away noise, which is 10, so it becomes 5. So now we're at the end of our end while, so we go back round. While net is greater than noise. So now net 5 not greater than noise, which is 10. So goals has only gone up by 1, so goals equals 1. Okay. Right, let's mark this then. So as long as you explain it, you can do it as a paragraph, as a couple of sentences, however you do it, but you've got to explain that process. You can't just come up with the answer and get all the marks. So here we've got, for the first question, net equals 5, which is less than noise. So net is not greater than noise because net equals 5. I've clearly done that calculation, so that's going to get me 1 mark. Goals equals 0 for your second mark. Okay. And then for the second question, we've got net 15, which is greater than noise. Yeah, is greater than noise. Runs the loop once, so goals equals goals plus 1. Net equals net minus noise. Net is no longer greater than 15, therefore, than 10, which is noise, so goals equals 1. 3 marks. And there are your answers to that question. As long as you write it in an understandable way, you should get the credit for the marks, as long as you meet those bullet point steps.
And that's everything you need to know about reading algorithms for your computer science GCSE. Well done for taking part, and we will see you next time.